Problem number 9 requires us to calculate the current that is flowing in each resistor. The logic here will be to replace all the resistors with one equivalent resistor, then find the current through that resistor, which is the current for the total load. Subsequently, then, reversing the process, we calculate the current in each branch, which then allows us to calculate the current in each resistor. This whole process will take some time, so I'm going to break it into two sections. The first section will be to find the total resistance. The following section will look at what we've been tasked with is to calculate the current flowing in each resistor. To begin, we find the parallel resistance of the resistors R4 and R5, which is 20.3 ohms. We replace that parallel combination with the equivalent resistor. Now we work out each of the parallel branches. For the top branch, the resistance is equal to the sum of the resistors R2 and R3, which equals 100 ohms. For the bottom branch, it's equal to the sum of resistors R4 in parallel with R5 and R6, which equals 20.3 plus 75 equaling 95.3 ohms. We could now replace the circuit to look like this. We are now left with the equivalent circuit here. So all that is left is to work out the effective resistance of the parallel combination of R4 parallel to 5 plus 6 and R3 plus 2, which works out to 48.8 ohms. We can now redraw the equivalent circuit now to look like this, or more compactly like this. So the total circuit resistance is RT, which is equal to 128.8 ohms. The equivalent circuit now will look like this. The total current supplied to the load is given by Ohm's law, voltage over resistance, which is 100 divided by 128.8, equaling 776 milliamps. Before closing off this section of the problem solve, I want to bring your attention to the fact that even though Father's Day is over, EcoFlow will be still featuring up to 48% off some of their great products. If you simply go to this web address, it will allow you to browse any or all of the products that EcoFlow are featuring. And remember, there's no cost for just having a look around. This brings us to the close of this section of the problem and its solution. If you want the full range of problems and their solutions, you can find them by going to my Stan Store at this web address. And finally, my newest course that I just added, Bridging the Gap Between Theory and the Practical. This course was developed specifically to solve the pain point of those newly introduced to the power industry. Whether you're an engineer, technologist, or electrician, this course is designed to give you a preview of what's ahead of those just leaving the halls of book learning and entering into the electrical power industry.